Hello, my name is Robin van Schendel and I am a student of Avans University of Applied Science. Today we will learn about box plots, right? So here are my initials. I will explain to you something about what quartiles are, what boxes and whiskers are, about the median and the mean, the interquartile range, and about outliers. A box plot is a graphical tool that helps to visualize the quartiles of a dataset, and it helps you to more easily illustrate the borders of your dataset and which data are outliers according to your borders.
What the hell does that even mean?
Okay, let me show you. Here's a set of data, right? Over here. These can be results from polls, they can be results from an analysis, or anything at all. But there is a problem with it though. Can you see it?
I don't know. I don't understand anything from this dataset.
Exactly. They are just a bunch of numbers. We humans can hardly understand numbers. We need something to help us understand this dataset. Now, if we wanted to know how this data was distributed around the middle point, a box plot would be a really simple way of viewing this. A good center point, right, for this box plot would be a median.
A medium?
No, not a medium, a median. Median. That is the middle point at which point, let me show you, at which point half of your data is above and the other half is below. It's quite literally a half point, a middle point, right? So here we have our data. And in this case, if you have uneven amount of values, your median would be just a point in the middle, the half point data, or whatever you could say it. But if you have an even amount of data, it would simply be the half point between your middle two data, like this, right? Now, if we draw this median right here, so right, this is our median. We will need to add the rest of the data as well. This is where the quartiles come into play. We will have to put them in one way or another around this middle point. Quartiles are basically 3 points that divide the total dataset in 4 equal groups.
Hey, if the median was the middle point of our dataset, isn't this then our second quartile?
Yes, exactly! Now stop interrupting me! Anyways, so the first quartile is the number halfway between the smallest number and the median. It is also the point where our interquartile range starts. Now let me just draw that. So I might as well just use this super 3D tool, right? Now, here we go. So this would be our first quartile. Now our second quartile is just like you said, our median. Now let's just connect these two, right? Like this and like this. So there we go. And as you might have already guessed, the third quartile is defined as the middle point between the median and the highest value within our dataset. So, like this. I'm just going to draw it again. You know, whatever. There we go. Now, this little box we created here is called the interquartile range, or I. Let me just use my tool here. IQR for interquartile range.
Oh, so that explains why it's called a box plot.
What do you mean?
Because it looks like a like a box. No, never mind. Go on.
Yeah, right. So if you are wondering if a data point you got can be removed from the dataset, there is a way to do that with a box plot as well. There's one thing you should take care of though, and that is that you need to decide whether the context of your data collection allows you to remove a data point.
How so?
Well, for example, if you are measuring the height of every student in a school, you can't really exclude one student for being freakishly tall, as he is a student just as much as the rest, even though monstrously large.
Okay, I see.
But if you are measuring something with a machine, for example, right, that has a certain measuring error, which has nothing to do with the thing you are measuring, and you can statistically explain it, then it is perfectly fine to remove an outlier.
Okay, I understand now, but how can you implement this in the box plot then?
Be patient, will you? We can show the limits within which our data point is reliable by using these whiskers. Let me just draw them, right? So here we got one of the whiskers. They're not really correct as the range of it, as the length of it, but it's just to visualize it, right? Now, and these whiskers can follow any rule that you demand from a data point. A rule of thumb, though, is to continue from each quartile, right? So this would be quartile 1, as we have already said, and this would be 3. To continue from each quartile 1.5 times the interquartile range. The interquartile range, as we remember, is this. So any point outside of these limits can be called an outlier. Like, for example, this guy. This is an outlier.
Neat.
Sure, a box plot is a really handy tool for visualization. You can also get a sense of the distribution of data within a box plot. By adding the mean to the box plot, one can visualize how evenly the data is divided around the median. A mean is another way to say average, by the way.
You're mean.
Stop that. Anyways, if the mean coincides with the median, alright, let me just show you. I'm going to Data Warrior here. If the mean coincides with the median, like for example here, we can see, if we scroll in, you can see that there is a red mark there to show the median. So if we see here 1.007 for the mean and 1.007 for the median, this means it coincides. This also means that the data is evenly distributed. But should the distribution be uneven, you can see that. Let me just add in the outliers again. You can see that there's a difference in what the mean and the so the mean is here, for example, 1.001, and the median is 1.007, which means that there is a clear difference and that the data is distributed, so it's uneven.
Cool. What next?
Next? What do you mean? That's it. A box plot is a simple method to give clarity about the nature of your data. Alright guys, that's it for me. See you at the next episode of Robin Explains.